So looking at this example, it says the weight W of bags of rice follow a normal distribution with a mean of 1,000 grams and a standard deviation of 4 grams. Okay. With the quiz, you're going to need to be able to recognize which distribution we're talking about. What's the dead giveaway for this one?
Normal.
Hmm?
Just normal.
It says it. And to be honest, normal distributions are going to say that they're normally distributed or it's a normal distribution. So you know you're working with that. Mean is 1,000, standard deviation is 4. To do part A, I want to find the probability that a bag of rice chosen at random weighs between 990 and 1,004. So what that looks like, you have a normal distribution curve that's asymptotic to an x-axis between 990 and 1,004. I'm looking for this area right here. Make sure that your 1,004 is to the right of where the mean would be located, and your 990 is to the left of where the mean would be located. Am I using normal CDF or inverse norm?
Probability would be normal CDF.
Exactly. So let me quit out of this. Second bars, normal CDF. My lower bound would be?
990.
My upper bound would be?
1,004.
My mean?
1,000.
And my standard deviation?
4.
4. I paste that. And that is my probability. Round it to 3 significant figures.
0.8.
Okay. And my hope is that you guys are doing this so you know that you're capable of achieving these numbers. Now it says 95% of the bags weigh less than K grams. 95% weigh less than K grams. They're giving you your percentage, AKA your probability. You are looking for the X value. So 95% weigh less than K grams. Am I shading to the right or to the left?
To the right. Wait, no.
Left.
Okay.
Because 95% weigh less than K grams. So this is the work, this is the method, this is how I can get those method points, by showing the normal distribution curve with the correct shading. How do I achieve the actual value? Second bars, inverse norm, because I'm looking for an X value. My area, what was that area? 0.95. For those who do not have that tail feature, I don't have to worry about doing any complements because I already have the area that's to the left of that vertical line. Anytime I have the area to the left, I don't have to worry about changing nothing up. My mean is 1,000, my standard deviation is 4. Unfortunately, I am going to have to adjust this tail, otherwise it's going to give me the wrong thing. So it is the left tail for those who have tails. Those who don't, you don't have to worry about it. When I paste, that is the X value that is going to be where 95% of the bags weigh less than, okay? For this one, it's going to be 1,006, or actually, let me round correctly. 3 significant figures will be what? 1,010 grams.
Miss Allison?
Yep.
Could we write like what we got on our calculator and then like kind of like draw like a 3-6 big squiggle thing?
That's fine, but whatever that final answer is going to be that answer that you get graded. Now it says for a bag of rice chosen at random, 1,000 minus A, W, 1,000 plus A is equal to 0.9. Find the value of A. This one can kind of be a little bit tricky, but what is 1,000? Your mean. So it's saying the mean minus some A value and the mean plus some A value is 90% or 0.9. So that essentially means from the mean, that's 1,000, you have some A value to your left and some A value to your right that makes up 90% or 0.9 of your area. So your job is to find A. And since A is going to be essentially the same on both sides, you just gotta, find it. So am I using CDF or Inverse norm.
inverse norm.
Inverse norm. And to be honest, the way that I would do this problem would be like so. I'm going to try to figure out what this A value is here, which means that I'm going to need this area right here. Since the mean splits this probability in half, half of 90 is 45. That lets me know that this blue area that I have is 0.05. Because remember, from the mean to the left is 50% of your data. So when I go into inverse norm to calculate my answer, my area I'm going to use is 0.05. My mean is still 1,000. My standard deviation is still 4. Unfortunately, I have to deal with this tail situation, but I chose that area to the left. So then that way, if I didn't have this feature, I wouldn't have to worry about doing anything extra. I go to paste, and that represents my X value. And not necessarily A, but my X value, okay? So if X is equal to 993, then A, and actually I probably should have labeled it this way. This is my mistake. I probably should have did this. This is some X value that the distance between these two is A, and this is some X value that the distance between these two is A. Because if 993 represents that particular value on your X-axis, A is the difference between your mean and that X value, which would be 7. Which means that that other upper value will probably be 1,007. And you can always test that. So linear models. All right, here's a few examples of the different types of questions that deal with linear models, okay? Old school, y equals mx plus c, okay? C is technically the constant, by-intercept. You're looking at how these different situations are modeled in a linear fashion, okay? A plumber charges customers a 50, is that euro, right? Euro? I'm not quite sure. I'm not up on my currency. I need to travel a little bit more. Let's just say $50. $50 call out fee, and then and then $80 for each hour he spends on the job. Okay. So you had to complete this table. Normally, if it says to copy and complete, you want to copy that table down and then complete it. But for the sake of this, we are just completing. All right. So what is the cost after 0 hours? 50. Because if we are initially being charged a $50 call out fee and then each hour is $80, then we are starting with 50 no matter what, just to basically sit down and do the call. All right. So then after 1 hour is how much? 130. Next one, 210. After that, 290, and then 370. Exactly, because it's $80 for each hour after that. So you continue to add 80 each time, plus 80, plus 80, and so on and so forth. That 80 represents your what? It represents our gradient, okay? Because that's how we are increasing as we go through each hour. So when it says to find a linear model connecting C and T, one, it's C and T, not X and Y. So when they give you variables, you have to make sure that you use those respective variables. C is technically our what? Our Y, our cost, the one that's dependent on our X, which is T, time. So instead of being Y equals MX plus C, it's going to be C equals MT plus C. Well, what'd you get?
I said C equals 80T plus 50.
And you would be exactly correct, because 80 represents our slope, how we're increasing each hour, and then 50 is how much we initially, what the initial fee was when we started. So that's exactly correct. And then hence, Anytime you see the word hence, that means using what you just found. Let's find the cost of a job which takes 6 hours. Well, I saw on some of your parent decks, some of y'all continue to add 80 till you got to 6. That's fine. But since you do have an equation, that just means I would plug in 6 for my time. And how many, what's the cost there? 530. Questions on this? So for this particular one, it says the amount of oil A left in a leaky barrel after T minutes is shown in the graph alongside. Okay, find the gradient and the A-intercept of the line, interpret your answers. Remember, anytime you interpret your answers in context, you always do it in context of the problem. You always do it in context of the problem. So, what did you guys get for your gradient? 5 over 1?
I got negative.
It would be -5. And you know it's negative because the line is going down. What's my A-intercept? 160, or more specifically 0, 160. And interpret your answers, okay? First off, if the gradient is a -5, and you're trying to interpret this in context of the problem, that means that you got to look at it from the fact that we're talking about a barrel. What's the barrel doing? It's leaking, which makes sense because if it's leaking, that means my slope should have been negative, okay? So that -5 means that the barrel is leaking what? How much oil? 5 liters every, there you go. So that -5 represents the barrel is leaking 5 liters of oil per minute. That's exactly how you would interpret that answer, okay? Then the 160 represents what? How would I interpret that answer?
How much?
In context of the problem.
How much oil is in the
There, so how much oil is in the beginning? So there's 160 liters at the start in the barrel before it starts leaking 5 liters per minute. Okay? So what's the model that connects A and T together?
A equals -5T.
Yes. What's my Y-intercept or my A-intercept?
Oh, okay, it's plus 160.
Exactly. Remember, it needs to be in the form of Y equals MX plus C. You got your slope and you got a Y-intercept. Only time there wouldn't be anything there is if we started at 0. If we started.
I think I was looking at the one on the
Okay. Then how much oil will be left after 15 minutes? Well, I already have my equation, so then I just plug in 15 minutes for T, and what is that? What's -75 plus 160? 85. So 85 liters. And then for what values of T is it reasonable to apply to this model? Now, let's talk about this. Something that you guys should have watched about in the video was about an extrapolation, right? Extrapolation happens when there's a particular value that's outside of the data values that you're given. It applies to a more like a scatter diagram and a line of best fit, right? I think there was an example where like the line didn't go through all the points. It was more like an approximation. In those cases, you can't predict anything outside of what you're given, okay? But in this case, since it is a line that's modeling this situation, this oil leaking out of the barrel, you can't actually predict it until there's no more oil left in the barrel. Question?
Did you put like only like positive values or something?
Exactly.
There can't be negative liters.
Well, true, there can't be negative liters and our time can't be negative. Because remember, we're doing values of T.
So values of T. So
0 less than T less than 8.
That would stop me right here, but this keeps going after 8. And not just less than, but less than or equal to. Because it can't equal to. Oh, yeah, true. So then What's the time at the end?
36.
And you got 36 how?
I divided 160 by 5.
Mm-hmm.
That was how many minutes it would take for it to run out.
Exactly. Exactly. You could also set our equation, which is essentially the same thing, set our equation equal to 0, because then here would be 0 liters of oil, and then we can solve there as well. Questions on this? Online, we good?
I'm good.
Piecewise functions. You guys continue to watch the video. Is another representation of a linear model. It's just that you have like different linear pieces that make up one function, right? In this case, a triathlon consists of 1.5 kilometers to swim, 40 kilometers of a bicycle ride, and 10-kilometer run. The table alongside shows the times Elena obtained for each leg of the triathlon. So 36 minutes of swimming, and she only went 1.5 kilometers. Okay, that's why it's so low. 40 kilometers of a bicycle ride for 81 minutes. So 81 minutes, she went 40 kilometers. Okay, so that puts her right a little bit above 40. So technically it's like 41.5 because she already went 1.5 for the swim. And then 10-kilometer run. So 10 more kilometers, 54 more minutes. Says use this graph to estimate how far Elena has traveled after 1 hour. How would I do that?
Go to 60 minutes.
So I go to 60 minutes because 1 hour is 60 minutes and my units are in minutes. So I go to 60. I go up and then to the side, exactly. Now, of course, it's an approximation because it didn't fall on an actual line. But looking at our scale, what would be this right here? So if you give an approximation, that should be somewhere between 10 and 20, maybe like 15. So about 15 kilometers. Very good. So y'all know how to read a piecewise function. Last one, unless there's questions.
If you said like 14 or 13 instead, would that still like get you the right answer?
It will get you the right answer because it's an approximation. So in situations like this, IB usually gives like a give or take, like plus 3 or minus 3. You know, as long as it's within the actual grid, like those two values. Where am I? All right, and then the last one, another piecewise function, one that's a little bit more involved. The graph shows the cost of hiring a squash court. Find the cost of hiring the court for 45 minutes.
Like around, yeah, 25.
Look again. 45 minutes on your graph corresponds to what part of this piecewise function? True. So then you got to look at where 45 minutes would hit your graph.
It'd be between 30 and 1. Or the.
Oh, you know, y'all are so right because I was looking at the wrong thing. So yep, is how much? 25, my bad. Well, my mistake. I was looking in between here, and of course I didn't even look at like the scale on the x-axis. Yes, but 45 minutes would fall right here because this would technically be 30 minutes. And so we're here. That's on that piece that's at $25. Yep, we are in dollars. What about 2 hours? 35. This is an example of a step function, a greatest integer function, a piecewise function. Okay, still basically pulling off values from the graph. Now, Kate and Peyton has spent no more than $15 each to hire a court. What's the longest time they can hire the court for?
Oh.
They can only spend $15 each to hire a court.
Oh, they can only spend
So then the longest time they could spend would be 1 hour. And the thing is that they only have $15 each, so that's $30. Unfortunately, 30 falls in between two particular values, and the truth of the matter is that you can't go up because you ain't got the money for it. So the only place they can fall is right within here, which is 1 hour. Okay?